What's up, YouTube? Welcome back to the channel. Today we are discussing elastic load balancing on AWS. Let's jump right in. What is a load balancer? A load balancer monitors the health of its registered targets and routes traffic only to the healthy targets. ELB, or elastic load balancing, scales your load balancer as your incoming traffic changes over time. It can automatically scale to the vast majority of workloads. Load balancers are servers that forward traffic to multiple servers downstream. In this particular instance, we're talking about for EC2. So this time of year, a lot of websites will see a spike in traffic due to Black Friday coming up, and a load balancer is the perfect way to kind of be able to balance that traffic. So you could have, as far as your application, you can have it running on EC2 or in containers, but you can have the traffic to go to specific instances based off the load balancer, and that's done using rules and listeners. So you may have an instance where you have your shopping cart would need to scale up, or your search functionality or your user registration functionality may get a higher load than normal, and the load balancer will put in place will help to prevent your site from crashing, for one, because you'll have protection with the load balancer, and it's going to distribute the traffic or the incoming requests to the node or resource that has the least amount of traffic on it. So as you can see here on this diagram, we have the load balancer being the front. So, and then each, based off the load balancer, you can configure rules or listeners, and this is what the client is going to hit. So, depending on how you configure your load balancer, like I said, you could have it. You can have one listener pointed to a target group for just checkout, or you could have another target group for registration or search ability, anything like that. But all of this is based off the rules that you set up on the load balancer themselves. And in this particular instance, a target group could be, like I said, an EC2 instance, or it could also be a lambda function also. So why use a load balancer? So a load balancer exposes a single point of access to your application via DNS. It can provide SSL termination, which is HTTPS for your application, HA across zones, high availability. You can have separate public versus private traffic. Spread the load across multiple downstream instances. We talked about that being EC2. And this is managed by AWS. So basically, AWS goes in and configures it for you. Sets it up for you initially, but then you kind of configure it to whatever your application needs are. And then finally, cheaper to use and set up your own load balancer. And out of the box, a load balancer is going to integrate with several of the AWS service offerings, Route 53, EC2, CloudWatch, just to mention a few. All right, so AWS supports 3 different types of load balancers. As of this video, there was a 4th one, but it's deprecated, which was the classic load balancer. So you won't see that one in the console, but you will see a ALB, or application load balancer, NLB, network load balancer, and then the gateway load balancer. So I've used a application load balancer before in my projects. So this supports HTTP, HTTPS, and WebSockets. And then a network load balancer supports TCP, TLS, and UDP protocols. Okay, some things to know about the classic load balancer. It's like I said, it's old generation, deprecated in the console, supports HTTP, HTTPS, TCP, SSL, supports IPv4 and IPv6, and it also supports EC2 instances with any OS currently supported by the EC2 service. Next, we have the application load balancer. So this particular load balancer works on layer 7 of the OSI model, which is HTTP. We already said it supports HTTP, HTTPS. It also has built-in WAF, or Web Application Firewall supports CLS offloading, and has support for sticky sessions to route requests from the same client to the same target. So in many cases, a load balancer is gonna the traffic is gonna bounce between one or more of the targets. One or more of the instances in the target group. So what the sticky session does is just ensures that it stays with that entire instance or whatever resource that it's using. It's going to stick to that same resource throughout the entire life cycle of the request. So it's good for different types of applications. So just a matter of if you need that type of session for your application. Next, we have it also supports Lambda functions as targets. So the next load balancer that we have is the network load balancer. Like we said, it works on the TCP and TLS protocols. This one differs from the AOB because this works at the layer 4 traffic in the OSI model. But this one also has support for sticky sessions. So this one, since this one works at a different level or different layer of the OSI model, this one is good for like high traffic sites. So if you need to process thousands of requests per second, you would want to use a network load balancer over an application load balancer. Also, the NLB integrates with Route 53. And then the final load balancer is the gateway load balancer. This one also operates at layer 4 in the OSI model. You can deploy third-party virtual appliances, scale your virtual appliance instances automatically. So this gives you the ability to scale up or scale down using the EC2 auto scaling support. And this one provides continuous health and performance metrics of your load balancer.